Good morning, everyone, and welcome to Track A. My name is Wade Wilson from the County of Santa Clara, the Technology Services and Solutions Department. I will be your moderator for the Track A sessions. I hope all of you are enjoying GIS Day so far. Next up, we have a series of speakers who will talk to you about how they are using GIS technology in their fields. Again, if you have any questions for our speakers, please type them in the chat, and we will answer your questions after the presentation. Before we get started, I have just a quick announcement. For the County of Santa Clara Assessor's Office attendees, if you would like to claim BOE credits, please make sure to join this webinar with your full name and county email address. With that out of the way, I'd like to introduce our first speakers today, Jason Caldwell and Eric Ingbar from Sanborn Map Company. Jason is the Vice President of Business Development and Sales at the Sanborn Map Company. He has 20 years of experience in GIS, remote sensing, and mapping environments. He has completed business consulting activities that have provided clarity and visionary direction for a wide range of customers. Jason started his career in a map production setting prior to his consulting assignments and uses his combined experience to provide education about the power of remote sensing and integrated geospatial solutions. Our other speaker, Eric, has more than 30 years of experience in mapping, data management, GIS, and spatial analysis. His career has included fieldwork, regional spatial modeling, and forecast algorithms, evaluating and designing GIS systems, and designing and coding enterprise information systems. As a senior consultant, Eric is often in the role of business analysis, determining needs, requirements, and assisting in determining client-focused, practical, spatial, and non-spatial information systems. And with that, I will hand it over to Jason and Eric.
Thank you so much, Wade. We appreciate that, and I appreciate the invitation to speak today. We're going to jump right in. We only have about 25 minutes to go over this discussion, which is to talk about democratization of data, as well as understanding the challenges associated with democratization and how to look at data governance as the capability to support those challenges. Quick agenda. I'm going to go over quickly who Sanborn Geospatial is, so you have a context in terms of our company and our history. Then we're going to jump right into the discussion of what the real problem is, which is this data tsunami that we're all faced with on the geospatial side of things. As we crosswalk that tsunami, what we will discuss is data democratization and how that supports, access to the data. And then Eric's going to jump in and talk about the challenges associated with data democratization and how we can all work together to fix those challenges. So as a real quick review, a lot of people aren't familiar with Sanborn. If you're not, we are the oldest mapping company in the United States. You can see on this timeline here on the left-hand side, we started making maps in 1866. And throughout the time of working in the geospatial business, the company's really been at the forefront of most of the technologies that we use today. An example of that, we were one of the first companies that developed a digital orthophoto. Prior to that time, it was all done through hard copy maps. The actual customer that we delivered that product to was Clark County, Nevada. We delivered that on an 8-track tape in the back of a refrigerated truck. So times have definitely changed, and it's always interesting to kind of talk about that, because that's really what we're going to talk about today is with the changing of times and technology, the amount of data that we're receiving is extraordinary. However, before we get into that, I want to kind of talk a little bit about the history and the historical maps that Sanborn created since 1866. All these maps were pretty interesting because they actually did include some level of democratization. But these maps are actually now available as public domain raster maps from the Library of Congress. But there's also data governance that Sanborn had to actually maintain over the course of time to make sure that these maps are updated and distributed to the proper people. This particular map is interesting to me because I live in Colorado Springs, and this happens to be a map from 1916 where it shows actually the elementary school I went to. And so it's always interesting to look at these old maps because they have a lot of detail on them, such as construction type and different details in terms of the size of the building and what the building is used for. Even more interesting to me is they've actually turned my elementary school into a brewery now, so I can go drink beer in my 4th grade classroom right in this building. And it's always cool to see that on the historical map itself. So Sanborn in general is a geospatial company. That's all we focus on. We don't have engineering arms or any other type of insurance or any other type of arm. And so the focus purely is on geospatial. We provide a range of services that cover all aspects of geospatial, from selling third-party data to doing custom acquisitions and productions, to doing spatial analysis, all the way through application development and strategy and decision support type of component. It's always interesting because as we're talking about this discussion of the geospatial or data tsunami, Sanborn actually contributes to this, right? Because we're flying data all the time, whether that's LiDAR or imagery or doing analysis or whatever it is, right? I mean, that data is going to our customers and it's creating essentially the tsunami of information that customers are starting to use. So we felt like it was important to kind of talk about this subject because, you know, we are part of the problem, but we also feel like we're part of the solution, and that's what we'll get into in the rest of this presentation. Before I do that, I want to introduce the team here that's on the call. Sanborn last year purchased a company called AppGeo. Really, the combination of these two teams rounded out what Sanborn had to offer. We were what we feel is the best in class in terms of being able to provide the data acquisition and data processing capabilities. What AppGeo brings is a very strong strategy and solution support function, as well as some application development capabilities. And you'll hear that from Eric's talk today. So as we get into it, the one item I wanted to focus on is strategy and decision support. Through the AppGeo connection with Sanborn now, AppGeo has actually completed over 30 states of strategy and decision support functions. As part of that, we also completed FGDC GIS Strategic Plan Guide for the FGDC. And so the reason why I bring this up is I do feel like you have experts on the call today to talk about this data governance and democratization strategies. And we have provided this type of consulting to communities across the United States and beyond. So let's talk about, you know, the increases of data volume that we're always seeing in this space. And I'm going to talk about a couple of different use cases here so you can kind of get an example of where the problem is coming from. This particular one, I think a lot of people probably on this call are familiar with 3DEP and the USGS program that is 3DEP, where they've gone through and updated the USGS NED-DEMS to a LiDAR DEM for the entire United States. It's an incredible program that the USGS has taken on, and they've actually, they're very, very close to completing the first iteration of this project. What I wanted to show you here is what that data looked like as a USGS NED 10-meter DEM. That's the image on the left here. And then the image on the right is equivalent to what is a QL2 product today, or a 2 points per square meter product. So you can easily see the difference in terms of quality and why we would want the data that's on the right. It's going to be able to answer a lot more questions for us, but that does come with a little bit of pain, which is the amount of data that is essentially being produced when we look at this. So when we look at a QL2 spec, you know, it's growing. If we're looking at the state of California alone, it's growing from 16 terabytes to 48 terabytes. If we went up to a QL1 spec, which is 8 points per square meter, we expand that from a 48,000 gigabyte to 192,000 gigabyte size. So in general, this is just one illustration of the pain that we're dealing with in terms of the data volume that we're all receiving and able to work with. A couple other examples. If you look at the last 6 years, what you're seeing here in this map and the graph on the right-hand side is all the different types of satellites that are available and different Earth observation capabilities that they provide. So some of this is imagery, some of this is non-imagery, but other type of data, such as meteorology data. In general, what we're seeing here is a huge explosion of information that is coming in that we all can access. And it really provides, you know, a wealth of information to be able to make our jobs easier and to be able to answer questions of our stakeholders better. However, it's a ton of data, right? And that's the focus of this initial part of the presentation. The other one is IoT, right? I think a lot of people are familiar with IoT and how great IoT is, you know, for the geospatial community and beyond. On the left-hand side, we're kind of showing the growth of smartphones, and that's definitely contributing to the IoT aspect, as well as if you look at Google Maps, that essentially has paralleled the growth of smartphones and the Apple iPhone launches itself. On the right-hand side, this is where it gets kind of interesting because it expands well beyond smartphones and the information that we're going to be receiving. This is a concept that Microsoft has shown in the graphic here about the digital twins and all the different sources of information that we're going to be taking in to enable a smart city, which is very close to what the GIS professionals are interested in. The one point I wanted to make here as we go on to the next slide is that, you know, just consuming data and just receiving data doesn't necessarily give you what you need, right? You need to be able to make observations. You need to be able to pull information out of the data that you're receiving to be able to essentially create actionable solutions. And so just one illustration of that is, I think a lot of us have heard about the protest march and the insurrection that happened in DC several years ago. There was a lot of initial information, a lot of initial data that was provided, which were the cell phone pings. But until we could get to a deeper understanding of the metadata and what was behind those pings in terms of information, we couldn't actually do much with that data. So it just gives you an understanding or a metaphor for what this looks like. So as we talk about geodemocracy, geodata democracy, it's a lot more than just providing open geodata, right? There's a lot more to it than that. We feel like there needs to have a cycle of information that goes through. The first step is opening that data up, but then enabling data tools to be able to pull location-based information out of it. And as we continue to go through this cycle, we start understanding the insights that answer our business questions. And really, in a lot of cases, that's going to actually impact us where we actually need further data. So it's actually going to compound this challenge of the data tsunami that we've been talking about. The other concept I wanted to talk about is really the user type and the user communities that we have here. In general, we've broken it down into this pyramid. The base of the pyramid is public and other stakeholders. Usually they're the last ones to get access to the data. However, this represents the largest user community within this space. As we go up, there's the professional and GIS users. I think that's probably most of the people on the call today. These are people that have some level of expertise being able to use GIS software. And then we go up one step further, which is the research, the universities, the military, where these are kind of the early adopters of the data, and really they can build whatever solutions they want. And so the concept that we're trying to show here is that we have to recognize that the population that's going to grow the use of geospatial data over time is going to actually be at the bottom of the pyramid. And we have to enable those people, because those people aren't necessarily GIS professionals. They're definitely not typically research level type of people. So we have to make access to the data easier and better for them to be able to actually get the most ROI out of the data that we provide. So just a couple examples how we can democratize data. I want to show one tool that Sanborn has produced over the years based upon input from our customers. This is what we call the Sanborn Geodata Explorer tool. This tool allows for customers to be able to find their data in a self-serve mechanism. It allows them to visualize the data, run some analysis on the data, and then also access specific web services, as well as complete a clip and ship download. The reason why this tool was built is because we had many customers coming to us, fighting the challenge that they had with their open data programs, and they had to redistribute data to their end users and their stakeholders, and they didn't have an easy way to do that. And so the concept really is to kind of lay out the foundation of a solution that enables the customer to easily get access to the great data that Sanborn is providing to our clients and that you're trying to provide back to your stakeholders. Another illustration of this, and I think it was talked in the presentation just before ours, is kind of looking at what Santa Clara County has done over time. On the right-hand side here, this is the Wayback Machine, kind of looking at the previous iteration of Santa Clara County's version of the website that provided interactive maps. And part of that solution was a 57-page document of instructions of how to use the data. When we look at what Santa Clara County is doing today, which is really on the left-hand side here, it's much more intuitive, much more interactive. There's tutorial videos, there's all kinds of information, and a lot more data there as well to be used. So it's just giving you an illustration of where we've come from and where we've gone in terms of the capabilities of democratizing data and getting data into people's hands, and not just getting the data in their hands, but educating them in terms of how to use the data, how to create maps, how to work with the data, and giving them easier ways to access the data. So as we think about this, there's existing challenges that we're all going to be faced when we think about democratizing data. Data storage, where is that going to be hosted at? How do I make sure that my end users and the public and whoever else is going to need access to this have an easy way to discover the information that they're looking for? How can they visualize it, and how can they analyze it? So on the right-hand side, we have a Venn diagram here, which really talks to this, right? And the idea and the concept here is, yeah, we need to make the data available. That's the right-hand side there, the data democratization, but it needs to be coupled with the education and the self-serve analytical tools to be able to create the data-informed decisions. And that's really the holy grail that we're looking for, is being able to enable the end users to quickly get to the decisions that they need to make in their business use cases. So with that said, I want to hand it over to Eric. I've kind of set the tone for the problem and the thoughts about data democratization. I think we all like that concept, but it really gets to the fact of how do we deal with all this data that we're going to have and how do we enable that data. So thank you so much for listening. Eric, it's all yours.
Thanks, Jason. Before we turn to discussing how we cope with the challenges that Jason's laid out, think about what happens when we have a success. And Landsat data is a great illustration of that. Landsat's the longest running Earth observing mission that we have. Data from Landsat's always been available. But as this graph shows with that blue line, there has been a cost until 2008, and sometimes a significant cost per scene, $4,000 a scene. In 2008, they got rid of the cost structure, went to free. There's also a technology barrier, right? Magnetic tapes that Jason referred to. Some of you may be familiar with those or may remember those. Then CD-ROMs, and then the internet as a distribution method. So cost and technological barriers. Look what happened when those fell, and the use of Landsat data became much easier. And that's shown with the orange line that shows you the number of citations in scholarly publications. It balloons by more than 400%. So when we get data democratization right, kind of like Jason showed you in the viewer application as well, it has tremendous benefits. Next slide, please, Jason. Thank you. But there are also weaknesses. So some of those are listed here, and I won't go into each individual small bullet, but some major categories of weaknesses we encounter in data democratization have to do with security, bias, inequitable or unequal access, and data quality. As GIS professionals, we're probably all pretty familiar with the data quality issues, but think about the inability to even access data and our goal of building applications to make that data more available. But as we do that, are we also addressing bias in the data we collect, either wittingly or unwittingly, and security issues as well? And above, we said that an outcome of democratization is more information. These weaknesses can actually work against us in terms of creating information that's reliable or effective. Back when data lived in a box in a private garden, we still had these same problems, right? But when we democratize the data, they become larger, and that box can become a Pandora's box, like you see in the illustration. And like the myth of Pandora, we may unwittingly release evils and imprison hope. But you might be thinking, okay, great, that sounds very negative, Eric. What do we do about this? So let's turn to that next and think about that. Well, we'd suggest that these weaknesses of making data and applications available democratically can be addressed through actively governing how we cope with geospatial data. So geospatial data governance is not geospatial data management. Geospatial data management is things like how we update specific kinds of data and so forth. Rather, governance is the framework in which that management takes place. So for example, a governance framework that we might come up with might include ideas like, hey, every data set has an owner, a steward, a catalog entry, a defined quality control process, checkpoints for publication and sharing and assessment, and mitigation for privacy and confidentiality in various uses. So that's the management that comes out of that, those policies, those ideas, is how all of these ideas are implemented. So pause for a moment and think about that data tsunami. It comes at us. How do we know what's good data? How do we know what's bad data? How do we know whether an application is in some way conveying bias to us? Let's look at a hypothetical way we might use these ideas to shape up a fitness program for data democracy, if you will. So let's pretend for a second that we work for a hypothetical organization and our hypothetical managers or directors or whomever have said, hey, we have great data. Let's make it as available as possible to everybody. So they've given us this bedrock data governance principle. Data are open by default. And for us geospatial folks, hey, what does that mean? Okay, great. Hey, boss, we should do this through a hub site, or let's create an open data portal or a web map interface. We'll just start pushing stuff up there. Well, we've all seen this approach, right? Hey, we're just going to put everything up there. Add some use credits, buy some use credits, fire up some wizard-like tools. We're back to our managers with mission accomplished. Everything's good, right? But what if we put out contradictory data? And I think Todd talked about this a bit for Cook County. What happens if we're providing stale data? Would we be better off by creating some governance around how we go through this process? And you'll notice that in each of the sort of shape up programs that I have here for the 4 weaknesses, there's the idea that public clarity. People should be able to know and to tell how data has been processed, presented, collected, and is being given to them in terms of those 4 categories of weaknesses. So those are important, and really that's the role of governance, right? Is to not necessarily to address each of these things. Perhaps we can't eliminate bias because it's in the nature of our work or our business is that we only deal with some segment of the world or some segment of the population. But at least we can tell others that this is the bias that is ingrained into our data. So when we do that, then we're really increasing the value of data and the value of the applications that use those data. There's another side to this fitness program. It's kind of like the paying the gym membership. Governance does have costs if we're serious about it. So take a simple problem. Who pays for the quality control so that data can be published every month as opposed to once a year? Who even decides that? These are all questions that governance brings forward in a data democracy. We can't give you an answer to those questions. Those are going to vary in your world or your organization. But we can just try to alert you to the fact that data governance isn't something you can kind of make a spare time activity. Next slide, please. So I know it sounds hard, but really, in some ways, it isn't, because you're probably already doing a lot of this, right? Some of it's just common sense. But in general, as this slide shows, data governance starts from principles. Those lead to policies. Those get implemented through standard processes, requirements, and practices. That's kind of the left side of that table, of that chart. The other columns, which I won't read to you, are examples of all of these things. The right side looks more at the management side. What happens with regard to data sets and data as you begin to put in place data governance. So to give you just a couple of examples, policy is that we'll inform users about our data. So every data set has catalog entries that require a data dictionary and metadata and appropriate descriptor tags. And those catalog entries are made available to all data users. Okay, that's a data management task, the actual population of that catalog. But the governance policy is that everything will be described and be available. So I think you're kind of getting the idea here, which is take a step back, think about how you're giving data and applications to others, and then think about whether you've done so in a way or you do so in a way that's consistent and that really kind of deals with the problems that Jason and I have outlined with data. And I realize that in a short presentation, we can't go too deep, but I suspect that these are not unfamiliar problems to each of you. So a few closing thoughts. We hope we've got you thinking about a few of these questions. And, are you actively thinking about these questions and addressing them in some way? And when you use other data, it's a great chance to learn somebody else's data, somebody else's application. It's a great chance to take those same questions, take those 4 categories just as starters and think about it. Are you informed about what they're doing, how they dealt with those 4 problems? And I'm reminded of what the popular English data journalist Tim Harford says all the time. He says, I always get suspicious when I see data and numbers. And you're always hearing from him, if you read his posts or listen to anything he broadcasts, that when he goes behind the numbers, there's always some interesting information that isn't readily apparent just by looking at numbers. I think the same thing happens with data and applications. And as we move toward more and more data, right, so we don't drown in the data tsunami, we really need to help users to float above it and to see where they are with it. So we've shared with you some examples drawn from, building applications ourselves and applications that make lots of data easily available, really democratization tools, if you will. And we've also talked to you a bit about our approach to establishing explicit data governance as a way to make democratization really valuable. So we'd love to talk about on these topics. I think we have a few minutes for questions remaining, but otherwise do feel free to contact us, and our contact information is there.
Great. Thank you, Eric. Thank you, Jason. It does look like we have a question. What would be the good activities about data education other than tutorials?
Eric, do you want to take that one?
So what would be good activities about data education other than tutorials? Well, I think a wonderful sort of activity is to, just pick several example publications that are out on the web, places that are publishing or sharing data, and then maybe in just a lunchtime session, go through it, right? Just do it as a brown bag. Everybody's sitting in a room together, eating their lunch together and going, hey, do we understand how these data were collected? Do you understand how they were maintained? And if we even think about the business business or agency or organization that is sharing this data with us, do we understand what kind of bias might be present in their data? For example, let's talk about counting traffic on city streets. Right, that's usually done with tubes in the road. And so right there's a bias, right? The assumption is that something that can cause those tubes or the magnetic detectors buried in the road to count a vehicle are being triggered. Well, bicycles don't trigger it. Electric scooters don't trigger it. But those are road users. So we have a bias right there in our traffic counts, right? So that's an idea that I would put forward to you, which is kind of actively probe and maybe do so in a group, because many perspectives will lead to a lot more questions.
Great. It looks like we don't have any other questions. So thank you so much, Jason. Thank you so much, Eric. We really appreciate you taking the time to give us this presentation. So for everyone else, we will now take a quick 5-minute break, and we'll return back at 10:45.